Hey there, this is Seth Waters from Channel 9, coming to you from NDC Oslo in the beautiful country of Norway, which I've just learned, Felina, that this is the first time you're in Oslo.
True story.
Really?
First time.
Isn't it like super close?
Well, super close for you, maybe, American person.
Yes.
It's 2.5 hours by plane, so we don't really consider that very close.
Oh, I see. Okay, so why don't you introduce yourself, tell us who you are and what you do.
Hi, my name is Felina. I'm assistant professor at Delft University of Technology, where I research programming for everyone. So programming, end-user programming. I used to work on spreadsheets a lot. We have a nice Channel 9 show about spreadsheets too.
It was like a year and a half ago at NDC London.
But now I'm also researching programming for kids and how to get children excited about the great things that we do as programmers.
So one of the things is I emailed you. You emailed me back. You said, I want to talk about programming is writing. Is programming writing? Or how did it go? I want to get this right.
Yeah, so the title of my talk this morning was Programming is Writing is Programming.
Okay.
And it's about what programming can learn from writing and the other way around.
So you're using that as the impetus to teach children how to program, is that right?
Absolutely.
How did you get started in this?
Well, it started by me teaching at a community center on Saturdays. I moved to Rotterdam and then I was looking for a volunteering job and I ran into this club. And what happened to me was, I just thought when I was a kid, I liked games. So these children must like games. Let's program games.
Yeah.
But not necessarily everyone likes games.
Right, of course.
And the interesting thing is, I did some data analysis on Scratch programs. Do you know Scratch?
Of course.
It's
From
such
MIT,
a great programming
right?
system from MIT. And kids can share their Scratch programs online. And I wanted to know, what do kids do in Scratch? So I downloaded 250,000 Scratch programs and I analyzed what kids are doing. And one of the things we found there is that only half of the programs have user interaction. So they listen to mouse clicks or buttons. And the other half of the programs are not games or even programs. They're more like art. So with Scratch, you can also create drawings like we used to do in Logo when we were kids, at least I did.
Yeah.
Or they use them to create music or to create stories. And then I was like, wow, I had been projecting my view of programming, games on kids, whereas programming is really broad and we should try to, especially when teaching children, keep their minds open for programming. Can be many things. It doesn't have to be practical like an app or a game. It can also be a story you want to express.
And that's interesting. So you analyzed 250,000 Scratch programs and you found that the majority of them did stuff like art? Like you can draw inside of a Scratch?
You can draw inside of a Scratch program with a little pen. You can move the pen and make a drawing.
And then the other thing you said is there was three. One of them was they told stories. What was the other one that I missed?
Music.
Music, okay.
You can also use music. You can have it play notes. And of course, there are lots of concepts in music that also occur in programming.
Of course.
A loop.
Or like timing.
Or timing, synchronization.
That's
so music
amazing.
is actually a great way of teaching programming, but because we programmers are more comfortable with maybe a website or a game, lots of programming material, introductory material is geared towards that because I don't really know music or art, but I know a lot about games.
I see.
And because I had this joke in my talk this morning, you know this joke about a big fish and it's swimming and it runs into two little fish and the big fish says, "Hey fishes, how's the water?" And the small fishes say, "What's water?"
Oh, because they don't even know.
They don't even know. They have been in water. They've never been in air. So they have no clue what water is. And to a certain extent, this is also the case for programming. We don't really even realize that the water of programming we're seeing right now isn't everything that's possible.
So this is a way of us lifting ourselves out of the water so we can be like, oh, this is how they might perceive.
Exactly,
Okay.
and it's so cool. If you ask little kids, if you know programming, what would you use it for? They say the craziest things. One of the kids in my classroom said, yeah, if I can program, I would want to build a new nature for when humans have destroyed nature.
Dang.
Wow.
Did you put them aside and be like, hey, can I be the janitor in your building when you do this? Because I'll volunteer. I'm really good at cleaning toilets.
But kids are so creative like that. One of the other kids in my classroom, when I moved away from doing the games and I moved towards what do you want to build, one of the kids in my classroom said, I want to build a website for the local supermarkets. That's what I want. And he went there with his mobile phone and took pictures and he made a website for the local supermarket. what educator comes up with an assignment in which you say, let's build a website for this supermarket that already has a website, of course.
And I like the idea of having the folks that are learning decide what it is they want to do, because then it becomes less of an assignment and more of a passion.
And also, they will teach you about the things they're interested in. So this is what I'm really excited about teaching. I really want to be wary of me telling them what to build. It's a bit like giving them a box of Legos without the booklets.
Right.
Here's stuff, and this is how it stacks together, and this is what you can make. And now make whatever
something.
is in your brain and use this wonderful tool, source code, to vocalize your ideas and to make it in something we can then see and
So when you talk about writing, I'm thinking of like storytelling, and you're saying that programming can also be that, and that was what your talk was about. Is that right?
Yes, correct.
Why don't you describe that a little bit more?
So there are many similarities between programming and writing. Ultimately, if you think about it, writing is you have an idea. Like in my talk, I talk about a story where a frog murders diplomats.
Yeah.
You have an idea. And what is happening is you take your idea and you transform the idea into letters and sentences. It goes from an idea into letters.
Right.
And programming is the same thing. If you think of an app that tracks compliments, nice things that people say to you, you have this idea and you transform it into letters and sentences. So the process is different. It's very, very similar, even though the domains are different. And a metaphor we often use in programming is the engineering metaphor. Yeah, we're building, and so for architecture and scaffolding. But the difference between building and programming is if you're building a house, you're not building half a house to learn about building, but often with writing and also with programming is you use programming and writing as a tool to understand the domain better.
I see.
I don't really understand what I'm doing, so let me write some source code to start a dialogue with the computer about what is there. I'm modeling with source code.
Wow, that's deep. I was just like, hold on. Oh, you're like, oh, okay. That's how it understands. And we have to talk to it in a way that it understands, and so you're writing for its comprehension.
Exactly, and but this will also shape your own thinking. Like sometimes you have this vague idea, and you're like, let me do some sketches on paper, or let me try to write, for example, a talk abstract about this idea, just to get it in a form that will help me think about it and also helps me share it with other people.
Sure.
And in this way, writing is, I think, a really good metaphor because it is shaping your thinking, whereas the engineering metaphor, it also makes sense. It's not that the engineering metaphor is useless. It's useful in many different programming systems. However, it lacks that aspect where you say, I would like a house. I'll just buy some bricks and just stack them on top of each other and I'll see where it goes. That's not really a thing that works really well if you want to build a bridge or a house.
So how do you take the kids or the young people or whoever wants to learn program that loves storytelling, how do you move that into something they can work on in a programming environment? And I guess I'm getting to what you're doing here.
Yeah. One of the concrete things that we've done is we've taken comic books to the programming classroom, and then we say to kids, pick a story from a comic book and recreate that story in Scratch. And we have this wonderful Donald Duck magazine in the Netherlands. It's also a thing in Norway, but probably most Americans don't know it. So Netherlands has 17 million inhabitants, and 1 million have a subscription to the Donald Duck magazine.
That's why it's such a happy place.
It's very popular, and it's so nice because the Duckburg universe allows for many different types of stories. You have love stories where Daisy Duck is in love with Donald Duck, but you also have Scrooge McDuck and he wants to find a treasure. So the nice thing is we let kids pick a comic from the magazine and they can pick their own preference, but all of them know the universe, so they can read each other's story because they know the characters. We experimented also a little bit with Pokemon because that was really in
my
fashion.
Kids love that stuff.
However, not all kids know the universe well enough to really converse about each other's creations. And this is what Donald Duck, all the Dutch kids, they know it and they have the magazine. So this is why it's really fruitful for that.
So you get a comic strip and you have them program. And you have an example of it.
I have an example.
Can you show that to us here?
Yes, absolutely. So let's have a look at the right-hand side of the screen
and teach us some Dutch too.
Sadly, my material is in Dutch.
No, what's sadly nothing?
It's a great
Dutch
language.
is a great language.
So if you look at the comic, you see that Donald Duck is coming in and he says, "Hoi, Oom Dagobert. Hello, Uncle Scrooge. Donald, what do you have in your hand? It looks like a once, and then it's not Donald Duck because
Yes.
it's Magica the spell,
Oh,
and
I remember
she
her.
transforms, and then she says, "I have something that will make you feel better. I'm going to change you into a frog." Which in Dutch is a joke because "make you feel better" has the word for frog in it.
Oh, so they're like being funny in Dutch.
They're like being funny in Dutch. And this story, I picked this specifically because you have the shape-shifting, the changing. Two of the characters are changing, and this is something that Scratch also allows for. So if you look here on the left-hand side, you have a Scratch program. You see this character, it's now Donald Duck, but it's going to change. Let me press the green flag, and then you'll see what happens. Hi, Uncle Scrooge. Donald, what do you have there? It looks like a wand. That's right. I have something to make you feel better. Now you're a frog. And then this is the rest of the story. So you have these two changes. And here Donald Duck comes in, the real Donald Duck. And he's going to smash Magica.
Oh, and it's just following the program here on the right.
Yes, so here what you see is the source code.
Right here, right?
Yes, only for the witch lady. And here you have the source code for Scrooge McDuck, and here for the real Donald Duck. So they each have their own source code associated with it. And here you say, oh wait, I can set the language of this to English, and at least it's a little bit easier to understand. So here, for example, this is the source code for Magica. So you see it switches to the costume of Donald in the beginning. I can click this, and then it executes. That's a nice thing about Scratch, that I can just click this, and then this is what happens. So it's a very live and interactual environment. And the cool thing about this is, once kids have created this, they can learn about programming, but they can also reflect on the story. For example, this story ends, but Scrooge is still a frog. So you can teach kids about reflecting on the story. What do you think happens next?
And then
Will
they
he
can
stay
program
a
that,
frog
yeah.
forever? And then they can program that. So they can take their own creativity. And the nice thing is that kids do this exercise in really different ways. So some kids really focus on the storyline, like here, but you can also draw in Scratch. So you can make Donald Duck look different by adding things to it.
I see.
So some kids were really excited about the idea of making everything look like it looked in the comic. So for example, where she waves the wand, they would change the hand and add sparkles.
Oh my goodness.
So some kids are really excited about the visual part of it. Some kids are really excited about the story. Some kids are really excited about what happens next in the story.
I see.
So it's so much more free form. If you say, let's build a Pong game, there are fewer ways that you can extend a game than there are that you can extend the story. So it's really very much about fostering that creativity in the ways kids want to take it.
One of the things that I like particularly, because I love education, that's one of the things that I love doing, is I love the idea of creating a hole in someone's head. Like, for example, at the end of the story, there's a huge hole, and allowing them to fill it with the techniques that they just learned, right?
Exactly, because we've done the story. So if they want to add more, then they can do that.
That's amazing. So how are kids liking this? How are they receiving this? Is it good?
Yeah, it's definitely good. We just did an experiment where for 2 months we taught 8 and 9-year-olds integrated programming and language lessons. And the cool thing is they really start to think about programming in a different way. At the end of this course, we asked them, what is programming? And one of them filled out, it's like a puppet theater, but on the computer.
Oh my gosh, that's so deep.
I know.
It's like a puppet theater, but on a computer.
It's
Because
true.
effectively, that's what you're doing
That's
with code,
what you're
right?
doing. So it's more like pretend play with dolls. And of course, there's nothing wrong with games. And if people at the end of a more game-based curriculum, kids would say things like, programming is making games. Like with the engineering metaphor, it's not that one is better than the other, but it is we want to have the diversity of thinking. If kids are really engaged with games, that's good. If they're engaged with storytelling, that's good. So we're developing an introductory curriculum now where kids can make a choice. So their first lesson can be either a game or a story or an artwork. And they can choose what fits them best. Because all of those things are possible with programming.
So as an educator, though, let's just say you're a teacher and you want to do this and you want to explain it. Is it hard to manage like 3 different paths at the same time? How do you do that?
So we make booklets.
Okay.
So we give kids booklets and they can do it in their own pace. But the interesting thing is we try as much as possible to have the same concepts in each of the lessons.
Oh, I see.
So you can do variables. Yeah, now we only use strings because it's a simple program, but you can use variables here. You can use variables in a game. You can use variables in a song where you count the number of loops. So it's more the space that's different than the concepts. And then you could still, with the entire classroom, talk about this lesson is about variables. Look at how it occurs in different ways.
And do you find them, like, for example, let's say Susie is doing the drawing and Billy is doing the comic strip. Do they cross-pollinate and talk to each other about these concepts and how it looks like in their particular setting?
This is, of course, especially if you're talking about 8 and 9-year-olds, you have to encourage this type of meta thinking. Yeah, you have to say, okay, what's the commonality? But it's definitely something you could train. For example, this was my example comic, and I asked an 11-year-old in my classroom, why do you think I picked this comic? Is it because it's just my favorite? She says, no, it's because people change shape. They can see the application of, this is an experienced girl that has been in my classroom for a year, but still they can see the concepts and their application if you press them.
Now, if this is something like, let's just say you have kids, let's just say you're a mother and you're a programmer and you're like, I want my kids to learn how to do this. Are these booklets available? Can someone try this out? Is there a way they can be a part of the experimentation that you're doing?
Yeah, absolutely. We have an online course on EDX, although currently this course is also only in Dutch, but over the summer we'll record it in English as well.
Okay.
So edx.org is a platform, maybe you've already heard of it, that has lots of open courses, MOOCs we call them, massive open online courses. So people could go to EDX after the summer and then participate in this. And you know what's interesting? We did a study with 3,000 kids that took our online course, and one of the predictors for dropout is, guess what? Having a parent next to you. So if you have a parent next to you, you're more likely to drop out.
Really?
Yes. So parents of kids that want to learn programming, teach them the basics and then get out of the way.
Get out of the way.
Because obviously kids don't like what parents like, and you can encourage them, but don't look over their shoulder, because we found that it actually inhibits their enjoyment.
That's interesting. So
I know.
So you're saying give them the tools to create their space, say this is how it's done, and be like, okay, you go do something and then show me afterwards, or not even just not be involved? Or
sure, now, I mean, you can be excited without being present at the computer. So you can ask them, show me what you build. And also, of course, the same thing that could happen to them that happened to me, where you're like, oh, I like games. You know what I like when I was your age? Frogger, or something really simple. And then again, you push the game narrative. And especially since, IT is the way it is. So we have lots of male programmers, and we celebrate game culture to a certain extent.
Yeah.
So there's a big risk of telling your kid, hey, let's build a game, and they're like, oh, I'm not into that. And then you think, oh, they're not into programming.
Which may not even be the case.
Which might not even be the case.
Because like web programming is all about storytelling, right? Especially in a website.
And also maybe, this is more deep philosophical thinking, but maybe if we teach kids from the beginning that programming is storytelling, also, we will get different apps. Different websites, different, I don't know, whatever programming we think we don't have currently. So it's not even that an app is storytelling, it's also that encouraging the storytelling behavior. Who knows what, like the supermarket kid, who knows what they could come up with that we cannot, because we've already drunk the water of programming.
And it feels like every time I see something, I always have a sense, like in programming, I always have a sense that there's like a, just next to what they're doing, there's something a little bit better that I just can't imagine. And you're saying that with these kind of programmers, there always will be something better. Yeah,
because they're so creative. Right. So definitely teach them about the powers of programming, but don't talk about applications too much, because maybe they want to build different stuff that's probably cooler than what we adults can think of.
So I like the idea, because there's one thing that just came out called Minecraft Educational Edition, which is similar to this, except they're creating their own space in Minecraft, which is it's a common vocabulary for a lot of kids. And I love the idea of saying, here are some tools, now go do something and show me what you've got.
Exactly.
Okay, so if I want to start doing this right now, what are some principles that I should start with first? Because the question is, like, I'm a programmer and I'm going to start thinking about, oh, do this, but they may not have the tools to do that, and so I'm setting up for failure. What are some of the tools that you teach first for people to understand? Yeah,
so be aware, and it depends on the age of the children, and be aware that we have found, and this also fits with psychology research, that some programming concepts will only click in high school age students. So
okay.
procedures, abstract thinking in general, only happens really well if you're over the age of 12.
Okay.
And this is very old psychology research. So if you're talking about kids under 12, try to stay away from concepts like Boolean operators and variables and functions. As you saw in our little Scratch program, it mainly has
Steps.
action blocks. It's very procedural. That maybe you're thinking that's like bad programming behavior, but their brains aren't ripe yet. They aren't small adults. And the interesting thing is, for other fields, we really know age appropriate as well. Who says to their 8-year-old, hey friend, let's do differential equations?
Yeah, it's
you know it doesn't, you immediately feel that they aren't ready. They need some basic steps.
Right.
Whereas with programming, sometimes we see people, let's do a function with parameters. This is as hard as, well, maybe not as a differential equation, to be fair. But you need to take it step by step, and initially it will be very procedural, it will be simple. Let them do a lot of blocks, and only then say, hey, you have some repetition. Maybe we can do a loop. So be careful about concepts.
So you're saying if you're going to start with something that has a set of steps.
Yeah.
And then once they've got this set of steps, set a principle down, look at, well, what steps are you repeating? And then start introducing loops.
Yes.
Okay. After you do that, I mean, where do you go from there?
Yeah, so it really, again, depends on the age of kids. But if they're older, one of the exercises I did with a group of kids that were 11, 12-year-old is, do you know Mondrian, the Dutch painter? He has these paintings with lines and blocks. So I had kids draw a Mondrian, all of them in a classroom. And this already, the kids say, why are we drawing? This is supposed to be a programming lesson.
Yeah.
So they're already like,
I love the cognitive dissonance you make.
It's so cool.
Yeah.
So you have them compare the Mondrian paintings to each other. And then you have blue and I have yellow. That means if we're going to create a program that can generate all the Mondrians in the classroom, color needs to be a parameter.
Yeah.
And you have lines like this and I have lines like this, so the direction of the lines will be a parameter. So I have them exercise comparing stuff. And then we create code, and then first I make a blue block and then I make a yellow block and I put them next to each other, say what is same and what is different, and I like the color, and then I tell them, look friends, this is why we practiced comparing things. So you make it relate to the real world, and then you take out the color and you make it into a parameter, and then you see, hey, I make a yellow, I make a blue with the same block. So you really, if you're doing abstraction, take it step by step and relate it to things that they can do, like spotting differences.
I see. So I'm totally excited. I'm excited to do this. So where can people go to learn about your research, and where can they go to find out more about this stuff?
So the best place that they can go to is my blog, which is feline.com, where you can read all my research papers. We have the data sets there as well. If you want to play with the 250,000 Scratch programs we analyzed, they are on GitHub.
That would be cool.
You can find the link on my blog. We have the scraping source code and also all the programs there. So if people want to check like the use of their favorite block, that will be the place to go. And also edx.org is where my lesson materials will be. We have a course for kids that will be in English after the summer, and also we will do a course for educators. So all the tips I'm giving you now, starting from September, I'll put a link on my blog. You can subscribe to an online course that's specifically for programming educators, or teachers, people that volunteer at a code club, but also parents.
Sure.
If they really want to understand these type of educational development things of kids, then that would be a really good place to start. And it will be, I can't stress this enough, these courses will be free for everyone.
Oh my goodness.
€0 or dollars.
I'm excited. So I want to stay on top of this stuff, because just the way you explained to me, like, hey, you need to start this way, because I was all excited to teach my kids Minecraft education. I'm like, all right, let me talk about functions, let me talk file operations, and you're like, what?
How old are they?
Well, my oldest is 12, my youngest is like 4.
Yeah,
and
so be careful
I need
with
to be
the abstractions.
careful with the abstractions. So that's actually really good feedback, and it's good research that you're doing. Thanks so much.
Thank you. Thanks for having me.
Thanks for spending some time with us. Again, the great Felina. Make sure you go to her blog, felina.com, to learn all about what she's doing. My name is Seth Juarez, Channel 9. We're at NDC Oslo. We'll be right back with John Galloway and Magnus, who his name really describes his personality. We'll see you after this tiny break.